Hi guys. Today what I want to do with you is I want to go over how to identify what type of reaction you're looking at. It's really a very easy thing to do. We are only going to look at four basic types of reactions. These are the notes that follow in this after the video so that you'll have all of this in writing. So far we've looked at how to count how many elements, and we've used that to help us balance. Now we're going to look at how to identify the type of reaction that occurs. So we're only going to look at four types. So we're going to look at synthesis. We use the letter S as an abbreviation. We're going to look at decomposition. We use the letter D. We're going to look at single replacement. We can use the abbreviation SR, or we can see a double replacement, and we're going to use the abbreviation DR. Now, how do we know? All we have to do is look at the reactants. Remember, in a reaction, you've got the reactants on the left, and then the arrow, and then the products on the right. And we're only identifying whether something is an element or if it's a compound. How do we know if it's an element? How many capital letters do we see? We only see one. Remember, we learned that way in the beginning of the school year. How do we know if it's a compound? It will have two or more capital letters in it, okay? And that's really all you're doing is applying that to your balanced equation. So now let's look at synthesis. If it's a synthesis reaction, then the reactants will start with element plus element. The only thing they can do is come together to form a product. We don't look at the products. The products don't matter to us. We're only looking at the reactants to identify. So here I gave you two examples, Na, one capital letter, element, plus S, one capital letter, element. So that's a synthesis reaction. I don't really care what goes on the other side. If I'm just trying to identify the reaction, it doesn't matter, okay? And again, another one, here I have Al, one capital letter, element, plus O2. Even though there's that little 2 there, it's still only one capital letter. So we're going to consider that an element. So that would be element plus element. So this would also be a synthesis reaction. Now, if we look at decomposition, decomposition starts with only one compound. There's no plus sign. If we look back up here, we had element plus element. Or if we look here, we had Na plus S. Here, we only will have one compound, and that's going to break down into the products. So here I gave you two examples. Al2O3, which is two capital letters, so that's a compound, no plus sign, so that has to be decomposition. Here I have CaOH in parentheses with a 2 on the outside, but again, no plus sign, it's not separated, so that's only one compound. So that would be a decomposition reaction. All right. The next one is called single replacement. When we have a single replacement reaction, we have an element plus a compound, and that's how we know it's single replacement. So here I've given you two examples, Na, element, plus CaCl2. There's two capital letters, so that's a compound, so element plus compound. That's single replacement. H2, element, plus AlCl3, two capital letters, that's a compound. So element plus compound, that's my single replacement reaction. And then here, double replacement. A double replacement is when you have a compound plus a compound, and they kind of change places, all right? So two examples, HCl, capital H, capital C, that's two capital letters, so that's a compound, plus NaOH, there's three capital letters, that's also a compound, so compound plus compound, that's double replacement. Or here I have compounds that have polyatomic ions, our favorite, right? So here we know that's a compound because I see parentheses, I see more than one capital letter. So compound plus another compound, so this would be double replacement. And that's how you tell. You're looking at each part, but you're only looking at what comes on the left side of the arrow, what the reactants are, not the products. That's why up here I didn't even write down what you would have. And same thing here, I didn't put any answers here, okay? So like I say here, the products do not matter when you are identifying the type of reaction. You are only looking at the reactants to tell the type. And then I just kind of remind you the difference between elements and compounds. So we're going to do a couple examples. I have them here, but I'm also going to write them out for you. So I will use E for element and C for compound in the examples that I'm going to give you. Okay, so let's start with these examples here. All right, so up here, these are balanced equations. So now you actually have a product or products. All right, but again, you're just looking at the left to identify what type of reaction occurs. So I'm going to start here with K, element or compound. So when I look at that, I see only one capital letter. So that would be element. Okay, I have a plus sign, so I'm going to just copy that here. And then here I have one capital letter. So that would also be an element. I'm not looking over here, I'm looking here. Element plus element. So if I go back to my paper and look for element plus element, element plus element, that's got to be a synthesis reaction. So this would be S. I'm going to give you lines on the paper, and you can just use the abbreviations, but just to write it out. You don't have to write them out. You'll just give me that part. Okay, so that's the first example. For the second example, I have NaCl, element or compound. This would be a compound, right? Plus element or compound. This would also be a compound. So I have compound plus compound. I'm not looking here. Compound plus compound. So I go back to my types of reactions. Here they are. Element plus element. Nope. Only one compound. Do I have only one? No, I have a plus sign, so it can't be that one. Here I have element plus compound. That's not element plus compound. That's compound plus compound. So then that must be this one, compound plus compound. So this would be a double replacement, or DR. So on the line, you're going to have lines. You would write down DR, okay? Or you could write it out, but you don't have to. Double replacement. Okay, and see, the way that I knew that is because I had a compound plus a compound. Okay, let's look at a couple more. All right, let's look at this one here. Now, element or compound, I have more than one capital letter, so this would be a compound, but that's it, because here's my arrow. Remember, the product side I don't care about. So here I just have one compound. There's no plus sign. So what type would that be? So I go back. And this one, element plus element. Nope, only one compound. So that means it's got to be a decomposition reaction. So this would be on the line that I would have. I would write D for decomposition. So that's a decomposition. Decomposition. Okay. And one more example. Here, element or compound. Only one capital letter. So that would be an element plus element or compound. Here I have two capital letters, so that would be a compound. So I have element plus compound. So let's go back. Element plus element. Nope. Only one compound. No. Element plus compound. It's got to be this one. So this would be a single replacement. And on the line, I would write SR because it's a single replacement. Okay, and that's all you're going to do for this worksheet. You're not balancing any equations. The equations you get are already balanced, and all you're going to do, or I'm going to show you, this is your worksheet, and there's 5 of them I want you to try. Okay, so you're going to use S for synthesis, D for decomposition, SR for single replacement, and DR for double replacement. And you're looking at what comes to the left of the arrow, element or compound, element or compound, element or compound, and then you match it up with the type of reaction. Okay, and that's it. All right, I hope that helps. Email me with any questions. All right, and have a good day. Bye.